Hey, I'm Janet. I'm going to show you experiment optimization at Benchling. I come from academia, moved to industry, and I was in chemical engineering and biology, but now do software and machine learning. So I've seen a lot of high tech, bio and tech and chemistry. And one thing I've noticed is there's a huge gap between how science could be done and how it's actually done, and that most labs are not, in fact, using the modern methods that some of us here are very excited about. So let's fix this. For my part, I chose to do this from within Benchling because there's over 200,000 scientists and academics using the platform and over 1,300 customers around the globe. So I knew if we built it here once, it would scale and survive economic craziness. So lots of customers on our platform. And so what we built over the last few years is now called experiment optimization, and it's supposed to give you all of the insights into data and optimization that you could have if you had a high-tech machine learning data science team, but it's designed to be for scientists with no code. And so we'll jump right in. So let's imagine we're optimizing a bioprocess. Maybe we're trying to optimize titer and we're changing parameters like media, pH, temperature. You load your data set in here. You can upload as a CSV or run queries from the data models in our platform. And then all you have to do is specify what column in that data set you're trying to optimize. In this case, it'd be titer, and you ask for a given number of recommendations. And this launches a whole AutoML tournament with tree-based regressors. So we found these to be very useful across the problem types that we're seeing at Benchling. And yeah, so you can get some insight into how well these models fit your data. On the upper right, we have the training metrics from cross-validation. And down below, you can click in and see which of the different model classes were tested and ultimately which one won. In this case, it's a random forest model that best predicts the data. And since we know that experiments in biology are very hierarchical and often two rows are related or even replicates, we allow you to specify a grouping column which keeps rows together during cross-validation and lets you prevent overfitting to some degree. And so the next thing scientists want to know once they get a good model fit is which columns in my data set mattered most. So the data set I showed you had more than 10 columns, and this quickly figures out that pH, temperature, and media used are most important and can give you those relative importances. And then you can use this SHAP analysis and dig in and see which values of those variables were best. So here you can click into media and see that media A2 most often boosted the prediction of the titer for your data set. And the most exciting killer feature that we've added this year is the Bayesian recommendations, which is built on top of the Bayesian backend. Shout out to the team who's talking later. And for this, we take a best guess at discretizing the user's search space so that we can give them this global view of why a given set of recommendations was picked. So here are all the potential candidate experiments you could run next, sorted by the mean. And so you can get a sense of the three recommendations that were picked in this case, and where all the training data in blue circles lie along that distribution of outcomes. And so you can get a sense like, okay, it's recommending two pretty exploitative conditions and also one that's a little more exploratory in the sense that it has a lower predicted mean but high uncertainty. If you want to change anything about the search space, there's UI to control that. So you can change the step sizes, the min and the max, or exclude categorical variables that were seen in training. And you can explore the posteriors in a few ways. This one lets you see interactions between two of your feature columns. So you can get a sense of, say, how pH and temperature affected your predicted performance. And since it's Bayesian, we can also do the uncertainty associated with positions in that space. And then most importantly, you might want to know why a given recommendation was selected. And for this, we have allowed you to click through your recommendations. So left, right will control which recommendation you're looking at. And this lets you pick the parameter that goes on the x-axis. So this shows you in a one-dimensional slice through your higher dimensional modeling space, what happens when you change a variable. So this is as pH changes, you can see that it maybe gets better around pH 7 and worse on the edges, that this coordinate was recommended, and where the data lies on that 1D slice that supports the model's fit. And this project has been going on for 4 years, so we've seen huge success in a few different domains. Bioprocess development has been a really impactful field for this tool. but also gene therapy. People are optimizing all sorts of genetic editing particles and genome engineering as well. So, what genetic compositions should you use to get optimal titer, for instance? And some customers have already told us they're saving hundreds of thousands of dollars per quarter. So, we're seeing a lot of success just with this simple tooling. And so I feel like Benchling has added one small piece of making it easier to get these automated systems up and running in the sense that everywhere else I'd been before, you had to have a whole team of machine learning experts to get the kind of insights that this tool allows. And now you can either get it without those experts or you can have those experts get to the answers more quickly using our tooling. And with that, I want to thank especially the open source community. This was built on Python, so we use eval for the model tournament for the AutoML step. And then the Bayesian backend has been really great for doing the Bayesian recommendations. It was super easy to plug into and add our custom surrogate. And so, yay, open source software. And thanks to the core team who's worked on this project over the years, this is a select group of people that were particularly impactful. So, thank you.